Hello, everybody. We are going to be continuing on with our new chapter on energy and simple machines. After this lecture, you are going to be having a quiz. So expect a quiz next week. I'm not sure if it's going to be in the beginning of the week or at the end of the week. I will give you further clarification on that as we move closer to that point. So we are going to be talking about conservation of energy. Remember I told you that the law of conservation of mass, law of conservation of charge, you're going to be hearing that a lot. So this is just another form of it, conservation of energy. I'm sure you guys can already guess what it is. Energy cannot be created or destroyed, just like mass, just like charge. But it can be changed from one type to another. For example, electrical energy can be transformed to light energy, like a light bulb. You plug in a light bulb into an electrical socket, and that electrical energy is transformed to light. It could also transform to heat, same as a hair dryer transforms to heat, or sound energy, radio. So electricity doesn't make a sound that we could hear, but when it is put into a radio, it makes a sound. Another example is that cars transform chemical energy into kinetic energy by igniting gasoline. We do the same kind of thing. We take in food and we convert that energy into kinetic energy. Okay. Kinetic energy is easily transformed into potential energy and vice versa. It's kind of like a pendulum. Now, as you could see down here, this is a pendulum. It's going back and forth, back and forth. So the more it moves, the more kinetic energy it has. So while it's swinging, it has this kinetic energy. But for a split second, this little red circle is up at the highest point, and it actually stops for a split second. And there it has the most potential energy. So as it goes up, it actually increases in potential energy and decreases in kinetic because it starts to like slow down as it goes up. And then as it comes down, it increases in kinetic energy. You are going to be watching this YouTube video. I'm not going to play it now. I'm going to post it. But it is all about the transference of kinetic energy to potential energy. Objects can have both kinetic energy and potential energy at the same time, and we are going to talk about that a little bit later. Okay, so mechanical energy. Mechanical energy is the total amount of kinetic and potential energy that an object has. It's ME. Ke is kinetic energy, Pe is potential energy, and Me is mechanical energy. So it's basically just Ke plus Pe equals Me. It's just the total amount of energy that an object has. So we talked a little bit about Isaac Newton and how the apple fell on his head. So I figured I would keep with that theme of apples falling. And as you could see this little gif over here, it is an apple falling out of a tree. So as objects fall from a height, they lose potential energy but gain kinetic energy. So when they are up, for example, the apple in the tree, it is up in the tree and it's connected. It has nothing but potential energy because it's staying still, it's up in the tree, it's not coming down, it's not moving. It is just potential energy. Let's say it's windy and the apple falls. Once the apple starts to fall, it's gaining velocity because it's starting to move, and it in turn gains kinetic energy. As you could see up here, as one type of energy goes down, the other one goes up. They can't both be high and they can't both be low. As one gets high, the other one gets low, and vice versa. As long as the apple is still at some height above the ground, as long as it's off the ground, it will have some potential energy, but it will never have as much potential energy as it did when it was on the tree. So I will try to, here we have our apple. At this point, when it's up here, it is all potential energy. As it starts to fall, its potential energy goes down, its kinetic energy goes up, 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 until it's on the ground. Okay, another video that we can't watch together, but I will post. Okay. Oh, all right. Conservation of energy also happens in your bodies. When you take in food, your body converts it into chemical energy and fat that is stored and used. So that's why we need to take in really good foods, because that is converted into more energy. When talking about the energy stored in food, we call those calories. So basically, if you're counting calories, if you're on a diet or something, you all know what calories are. 1 calorie is equal to 4,184 joules of energy. We burn off calories by doing different activities. And if we were together in class, I would tell you to get up and jump. Most people complain that they don't want to get up and jump, but I make them, and we burn some calories together. So here are a few things that burn calories, a few activities. You actually do burn calories while you're sleeping. A lot of people might think that you're just not using any energy, but you are. As long as you're alive, you're using energy and you're burning calories. So this goes by body frame. If you're short and slender, if you're medium, like about average, or if you're tall and broad. So sleeping burns the least calories, and this is for 1 hour of sleeping. So if you sleep for, 8 hours, you're burning several hundred calories. Sitting burns a little bit more than sleeping. Eating, ironically, burns some calories, even though you're probably ingesting far more than those. Standing, walking, tennis, biking, and running. So all of those things do burn calories, just depending on how vigorous the activity is. Now this is a really great thing that we're going to actually end on, I believe. Yes, we're ending on this, but it's a great graphic. So here we have a roller coaster, and it is up at the top of a hill thing, and it has high potential energy and low kinetic energy. It's up at the top. The higher something is off the ground, the more potential energy it has. And when you're up at the top of a roller coaster, you're not really moving much, so you have a low KE. As it loses height, as it starts to come down to the ground, it gains speed. It gets faster and faster and faster. And the potential energy is transformed into kinetic. So down here, it gains so much speed that this is actually the fastest it's going to be going. And it's minimum potential energy and maximum kinetic, because the kinetic energy is the energy of movement. Then it goes up and kind of like levels out a little bit. It still has a low potential energy because it's not high up like it was here. And it still has high kinetic energy because you have the momentum going, but it's not maximum and minimum. However, the sum of kinetic energy and potential energy is always constant. So as one raises, the other one lowers. It's always the same sum. Mechanical energy is always exactly the same in a system. This is what we call a system. Okay? If you have any questions, let me know. You guys are going to be doing an Edpuzzle and a ReadWorks. There's no real math to do here, so those two things will kind of encompass everything: the conservation of mass, the kinetic energy, and the potential energy. You will be having a quiz next week. I'm not sure which day, and hopefully we're going to get into some labs after the quiz. So again, if you have any questions, I will be available for office hours if you need, and obviously you can email me. All right, have a good one.